So let's have a small recap whatever we have discussed in the last class. So that is related to confusion matrix and evaluation metrics of classification. So let us start with respect to that. What is meant by classification means where output variable is discrete. If the output variable is discrete, then it is called as classification problem. If an output variable has two categories, it is called as binary classification problem. It is called as binary classification problem. If the output variable has more than two categories, then it is called as multi-class problem. Right? Now, multi-class classification problem. Now, within that, we have discussed about the accuracy and misclassification rate, precision, recall, true positives, true negatives, false positives, false negatives, all these things. And I have given you an example, a homework task with respect to Y and Y pred. So where I'm going to consider in the Y plus minus, plus minus, plus minus, plus minus, plus minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Y pred 5 pluses and 5 minus. For this, what I'm going to do is first I'm going to calculate the accuracy. That is how many classified correctly. That is 1, 2, 3, 4, 5, 6. So accuracy is 6 by 10, which is 0.6 is the accuracy. Second one, I'm going to calculate the misclassification rate. Misclassification, that is 1, 2, 3, 4. So 4 by 10, which is nothing but 0.4, which is also 1 minus accuracy. Both are same. Right? Next. After that, third one is I have to make a confusion matrix. So I'm designing a confusion matrix for this. The confusion matrix where I'm going to consider with respect to actual and predict. Actual positive and actual negative. Predicted positive and predicted negative. Okay, you can consider with respect to like this. I'm considering the predict on this side, actual on this side, and I'm making the confusion matrix. Now I'm going to check how many of them are with respect to this true positives. Means actual should be positive and predicted also should be positive. This is the first record, second record, third record, 3 records I'm having. So next, actual should be positive, predicted should be negative. So actual should be positive. Actual positive means this one. And predicted negative, this one, 2. These 2 of them. So I'm going to take 2 here. This one and this one is considered as this category. So what I have predicted, this is called as true positive. This is called as false negative, because I have predicted negative, so it is called as negative, which is false negative. So I'm writing this one as false negative word, and for these 3 I'm writing as TP, TP, TP. Right? Next, coming to the next one, negatives. So this particular thing is predicted as positive and which is opposite. So false, it is a false positive. So actual should be negative and predicted should be positive. That is record number 1, record number 2. Only 2 records I am having, 2. So next one is true negatives. True negatives are with respect to actual should be negative and predicted also should be negative. That is 1, 2 and 3. This is the confusion matrix. For the given data set, this is the confusion matrix and this is the values of TP, TN and FP and FN. Right? Is that clear? Anyone has any questions up to here? No, right? So now we are having TP, FN, FP and FN. Now using these 4, I have designed the confusion matrix also. After designing the confusion matrix, now I'm going to calculate the first one called as precision of precision of positive, which is nothing but true positive divided by predicted positives. Predicted positives are nothing but TP and FP. Both are predicted positives. That is nothing but 3 divided by 3 plus 2. That is nothing but 3 divided by 5.6. Similarly, precision of negative. Precision of negative is precision of negatives. Negatives means predicted negatives. Predicted negatives are nothing but Fn and Tn. Both of them are predicted negatives, out of which correct one is Tn is the correct one, which is again 3 divided by 3 plus 2, which is nothing but 3 divided by 5.6. Next one is a recall. Coming to the recall, a recall of positive is nothing but actual positives. Actual positives are this one, that is TP and Fn are actual positives, out of which TP is correctly predicted. That is 3 divided by again 3 plus 2. In my case, 3 divided by 5 only I am getting for all of them. Okay. And a recall of negative. Recall of negative is nothing but total actual negatives. Actual negatives are this one, that is Fp plus Tn, out of which Tn divided by this one, that is nothing but 3 divided by 3 plus 2, which is nothing but again 3 by 5, which is 0.6. For everything, these are the 0.6 only we are getting. Okay, in this case. Okay, so now precision, recall, these are the things which we have completed. Now, apart from this one, we are having called as, next one is called as true positive rate. True positive rate. This true positive rate is also called as a recall of positive. Recall of positive and true positive rate both are same. Similarly, true negative rate is also called as a recall of negative. Both are same. Okay, true positive rate and true negative rate. So, true positive rate, that is recall of positive, is also called as sensitivity. Sensitivity. And recall of negative is also called as true negative rate, and this is also called as specificity. Okay, and next one is FPR. FPR is nothing but false positive rate, which is equal to 1 minus specificity. 1 minus specificity is called as false positive rate. And FNR is nothing but 1 minus sensitivity. Right? Now, the question is, sir, okay, formulas wise you have written okay, and it is also called as that one. But what is meant by rate? Just understand what is meant by rate. Rate means with respect to actual. Rate meaning is actual. When you are working on the true positive rate, what is the meaning of true positive rate? Means true positives, you want the true positives divided by actual positives. That is the meaning. So, TP divided by actual positives are this one. That is TP plus Fn, which is also equal to this one. Both are same. Similarly, if you go with a true negative rate, negative rate means you want with respect to actual negatives. Negative rate, you want negative rate. Negative rate means actual negatives. You have to write in the denominator with actual negatives. And in the above denominator, you have to write first two. True negative rate, for understanding purpose, I am saying in the numerator, you have to write this one. In denominator, you have to combine these two words. Numerator, you combine true negatives. You take the true negatives on the numerator. That is Tn divided by actual negatives. Actual negatives is nothing but Tn plus Fp. Similarly, if they ask you the question of what is FPR, for easy understanding, okay, FPR is nothing but positive rate they are asking, means actual positives. You have to focus on the actual positives. And about numerator, you have to focus on FP, false positives. That is false positives divided by actual positives. Again, that is TP plus FN. So if you write this one, TP, that is nothing but TP plus FN, whatever you are having. This TFPR is equal to FP divided by actual positives, right? So now if you consider this one, so that is nothing but FP divided by TP plus FN, which is nothing but 1 minus specificity. Okay, 1 minus specificity. So you can take in the notes, true positive rate, true negative rate, false positive rate, and false negative rate. Which is equal to Fn divided by actual positives. Actual positives are TP and Fn are actual positives, out of which Fn we are focusing. So true positive rate, true negative rate, false positive rate, false negative rate. True positive rate is also called as recall of positive. Both are same. True negative rate is nothing but recall of negative. Right? Yeah, all of them are 0.6 only. Done? Now, here I am taking the true class, predicted class on this side. So this is the prediction positive now. So it is called as true positive. This is called as false positive because I am predicting positive. Whatever I am predicting, I am writing in this side. And whatever I am predicting negative, I am writing that negative, negative, true, negative, false, and true. Right? Now, this is called as type 1 error. False positive is called as type 1 error. And false negative is called as type 2 error. Right? And what is the meaning of positives? True positives means actually it is positive, predicted also positive. True negative means actual negative, predicted also negative. False positive means actually is negative, predicted as positively. So second word indicates whatever you have predicted. False negative means actually it is with respect to positive, you have predicted negatively, wrongly you have predicted. Okay. So classification is nothing but whichever is true, that is divided by total. Misclassification it is nothing but which is opposite to that. That is 1 minus accuracy, which is opposite to that. And precision and recall, where precision is divided by true actual predictions, and whereas recall is divided by actual values. One is predicted values, one is actual values. Right? Now let us take an example here. I am having 1, 1, 8, and 90. For this data, if you calculate what is the accuracy means 1 plus 90 divided by total is 100. That is 91%. What is the misclassification rate is? Remaining 9 records. That is 1 plus 8, 9 records. 9 records divided by 100, which is 9%. Accuracy is 91%. Misclassification is 9%. Now precision, you are calculating the precision not only for positives and along with the negatives also you have to calculate. Right? Now, next one is called as specificity. Specificity is also called as true negative rate. True negative rate is nothing but true negatives divided by true negatives plus false positives, which is in this case 90 divided by 90 plus 1. And this recall is also called as sensitivity. Recall is also called as sensitivity. This recall is also called as true positive rate or sensitivity. Both of everything is same. Recall of positive, true positive rate and sensitivity. Everything is same. One and only same. Right? Sir, why they have kept these many names? Miss? in order to confuse us, nothing else. Okay. So just by using the word of sensitivity, specificity, all these words, just they are going to confuse. Because why they want recall of positive separately is available, recall of negative also available. Both of them are available. Now, if I say recall means, by default recall means recall of positive only. So for this, they want to keep a separate name. Recall of positive exclusively can we keep a separate name. They have created as TPR. Recall of negative separately will create a separate name called as TNR. They have created. Otherwise, recall, if I'm saying recall of positive is there, recall of negative is there. Two of them are there, right? So that is the reason they have created with respect to another one. Now, whatever we have done the classification metrics till now is for binary class. Let us assume there is a multi-class. Let us assume there is a multi-class. Now, how we are going to do that one and how TP and FP values will be there. Let us take an example, Y and Y hat. Let us take an example. Now, where in the Y output variable I am having multi-class problem. Let us take example of drug 1, drug X, drug I, drug J. Okay. I, J, K. Let us take K. Okay, drug K. Okay, 3 categories are there in the output variable. Actually, we are having 3. So, drug I, drug J, I, J. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. K. Okay. So let us take like this. You are having the output variable consists of I, J, K. 3 categories are there. Now predicted values 3 I's, 3 J's, 3 K's, and 1 I. Randomly I have written. Now for this we have to make a confusion matrix. Now how we are going to make this? One side I am going to consider actual. One side I am going to take predict. Whichever the side you are interested, you can select. I am selecting this side actual. This side predicted, because in the machine learning, the output also I will get in the same way. In the Python code, I will get the same way. Okay, whatever the confusion matrix function is available within the Python, it is going to take by default on the this side predict and this side actual. So I'm also going to work on the same way. Whatever the Python it is going to have. So first option is, what is the first option is I, J, K. I, J, K. Total 10 values, right? Now, tell me how many records are with actual I and predicted I. 1. Actual I, predicted I. Only 1. Right? 1. This one, actual I, predicted J. Actual should be I. 1, 2. This is I, yeah? J only, yeah? Let us, okay, done. 1 and 2. Actual I, predicted J. 2. Actual I, predicted K. Actual I, where is I? 1. Keep it here. Now, next. Actual J, actual side J and predicted I. 1, J and I, only 1. Now, actual J, predicted also J. This is the 1. Actual J, predicted K. 1, 2. Actual K, predicted I. 1 and 2. 2 are there. Actual K and predicted J. K, 1 and 2, but J is not there, 0. Actual K, predicted K, 0. Confusion matrix completed. Whether 10 is there means what happens, 20 is there means what happens. Confusion matrix only. This value is actual I, predicted also I. This value is actual is from this side, predicted is from this side. Then what happens? Actual I, predicted J. How many records are there? You have to observe and you have to write. That's it. If 20 categories are there means 20 rows, 20 columns you'll get. Matrix. Right? With each category. Now, within this, which is true positives and which is true negatives? That is the question. Now, here, the whatever you are having this one. For example, I'm working on the recall of I. Recall of I means total. What is the meaning of recall of I? Actual I's and true I's. True I's means actually predicted and really predicted also. How many records are there? One record, and actual I's are this one. Actual I's are this one, that is 4, which is 1 by 4. 0.25 is the recall of I. Here there is no word of true positive, true negative. There is nothing word. So you should not remember the formulas as TP divided by TP like that. You should not remember like that. Actually predicted by, sorry, correctly predicted divided by actual predicted, actual values. Correctly predicted by actual is called as recall. Precision of I. Precision of I means correctly predicted of I. Correctly predicted I divided by predicted I. Total predicted I. Total predicted I. So correctly predicted is 1. Total predicted of I is 1, 2, 3, 4. In this data set also again 1 by 4. Okay. So 1 by 4, 1 by 4. Don't get confused, but both are different. From this side, if you see 4, this side also you are getting 4. Okay. For let us go with J. Now recall of J. Tell me for recall of J. A recall of J is nothing but, what is the meaning of recall of J? Correctly predicted J's, how many records are there? Divided by actual J's. That is nothing but correctly predicted is only 1, because this is actual J and predicted also J is only 1 record is there. Divided by actual J's. That is 1 plus 1 plus 2. That is 1 by 4. Similarly, precision of J is nothing but correctly predicted J, correctly predicted as J divided by total predicted J. Total predicted J. That is nothing but 1 divided by 2 plus 1 plus 0, which is 1 by 3. Is that clear? So in this way, we are going to, here there is no word of true positives, there is no word of true negatives. For this class, remaining all of them are oppositely classified only. These 3 of them are opposite classified, these 3 also are oppositely classified. Is that clear? Done? So for the multi-class problem also, the concept remains same. Recall means with actual, precision means with predicted. Concept remains same. Whether it is, for example, in the same example, whatever I have considered, in the same example, let us take one more matrix. This time I will take the different matrix where this side I will take once again predict only. This side I will take with respect to actual once again, the same to same. But I, instead of J, I will write K here. Sir, why sir? To confuse you. To confuse you only, nothing else is there. Inside that, nothing else is there. Okay. And to whether you have understand the concept or not to check that one. Okay, K is K only. But this time, this is not with respect to true, na? This is opposite one. Now, this is called as true I. Then what is this is called as? False K. Then what is this is called as? False J. Then what is this is called as? False J. Then false K. Then what is this is called as? True J. Next. False I. True K. False J. Now true values are here, here, here. Now again you calculate once again for the same example, you calculate the precision and recall of J's. Calculate the precision and recall of J again. Confusion matrix changes means values will change. No. Concept is concept only. Precision of J means precision of J only. Precision of J will not depend upon the confusion matrix. Irrespective of confusion matrix, precision of J is there. Whether this side is there or this side is there, or, that is not important. Precision of J is nothing but how many true J's are there divided by predicted J's. Predicted J's means this all are predicted J's. That is falsely predicted I, falsely predicted J, and falsely predicted J plus true J. All of them are J's only. 2 times you have falsely predicted J. For I also you have falsely predicted J. For K also you have falsely predicted J. 2 times will be there. FJs. Is it clear now? The concept will not change as per the confusion matrix. In the interview, I will ask like this one questions. When we ask this type of questions, students who know the subject only will write the formula. Whoever has by-hearted this position, fixed, TP, TN, FP, FN, they'll fix and they'll come now. They'll fix the formulas and they'll write according to that. If I ask for formula means first they'll write the confusion matrix in this order only, then only they will write the formula. If I change the confusion matrix, what sir? Right? So here the concept we have to understand. What is the meaning of precision meaning? What is the meaning of recall meaning? Now, what is the use of precision and recall? Why all of them? What is the use of recall and positives? I mean, recall and precision. Why? What is the use of this one, miss? So to check whether our data is performing well. For example, assume there is a data set with respect to cancer, whether the person is having a cancer or not. Yes or no is the scenario. Let us take this side with respect to predicted side. Predict and this side actual. Actually, the person is having yes and the predicted as no. Similarly, actual also yes and predicted also no. Since you are having 2 categories, 2 by 2 matrix will be there. 3 categories are there means 3 by 3. 10 categories are there means 10 by 10. Matrix will be the same. Now, this value is actually the person is having the cancer. Actual, he is having cancer and predicted also cancer. For this, no problem. You have done correctly only. Now, the person actually having the cancer, actual cancer is there, but you have predicted no cancer. No cancer you have predicted. Now, in this case, what happens? The person will not take any kind of medicines and there is a high probability that he might die. Now, in this case, the actual is the person is having with respect to no cancer. And you have predicted cancer. Right? And you have given the medicines. Cancer medicines will reduce the age. They are not like with respect to multivitamin tablets to improve the immunity. The cancer medicines will decrease the age. That is the problem with the cancer medicines. Whoever gets the cancer, the age will be reduced. For example, they have to live actually 80 years means they will live for 79 years, maybe 1 year, whatever it is. At least some % of age will be reduced. I don't know exactly what percentage, right? But that depends upon the person to person again. So there are multiple calculations are there inside that. Now, there is a hospital in India. The location is Gujarat. Okay, there is a hospital in Gujarat in India where they have predicted for a person with no cancer, but they have predicted as cancer patient. And they have given the chemotherapy and all of them. Radiations and chemotherapy, so much of things they have done. And his age was reduced gradually. Now, he has claimed with a case in the court that stating that I'm not having cancer, but these people has predicted that I'm having the cancer and they have done the chemotherapy and radiation on me. And they have collected the amount from me with 12 lakhs rupees. Now, the court has given with whatever the judgment, along with this 12 lakhs, you have to pay additionally 88 lakhs. That is 1 CR you have to give for him. Because you have reduced that much of age of his value, where he can earn that money. Right? So this point is very much important for predicting. So in this case, which part is more important? False positives or false negatives, or with respect to that one means here we have to focus with respect to this value means precision. So in the given problem, for the given problem statement, they are going to clearly focus. They'll ask us to which value we have to focus. If they ask us false positive means we have to make sure our model which gives the false positive as the lowest one. If the requirement is this one means we have to focus only on that. If the requirement is false negatives, if the requirement is on false negatives, then we have to focus. We'll apply the multiple algorithms. First algorithm. We'll apply first algorithm. In that first algorithm, for example, let us take like this. Let me explain with an example. Okay, where I'm having a confusion matrix with respect to TP and FP and FN, where 90 and this is 91%, and this side I'm having with respect to 8 and this one is 1. Total 100 records are there. Okay, now this is the confusion matrix where I'm having this one as TP and FP, FN and TN. This is ML algorithm 1 has given me the output. Assume ML algorithm 2. Now 90 and this one is 4. Okay, this one also 4 and this one is 2. Now if you observe this one here, what is the accuracy for this algorithm? What is the accuracy of this machine learning algorithm, guys? What is the accuracy? 91%. That is 90 plus 1. 90 plus 1 divided by 100, which is 91%, which are correctly predicted. This one correctly predicted. These two are wrongly predicted. So in this case, what is the accuracy? 90 plus 4 divided by 100, which is 94%. This is ML algorithm 2. For example, if the given problem is to focus on the accuracy, means this algorithm is best. But the given problem statement says that we have to focus on the FN. In which case FN value is least? In the case 1. So this algorithm is best. We have to give this model. Though the accuracy is low also, still we have to go with this model on. That is the requirement. They want this one as the low. If that will be given in the problem statement. If they have not given anything, means by default it is accuracy. If they ask you to specially focus on the precision of positive, means you have to observe for every algorithm precision of positive value and which gives the best one. That algorithm only you have to save the model and you have to share to the client. If they ask you to focus on the recall of positive, means you have to focus on the recall of positive. If they ask you to focus on the FN, means you have to identify which algorithm or which model gives you the least FN value. Okay, now let us take a bank data set. Let us take a bank that is loan prediction data set, as everyone knows, right? Okay, loan. Now I'm considering this side with respect to actual and this side I'm taking as predict. Okay, the person will repay the loan, yes and no. Predicted also yes and no. Actually, the person will repay the loan. And you also predicted that the person will repay the loan and you have approved the loan and you have given the loan. Okay, he will repay and you are happy. But actually the person will not repay the loan. He will not repay the loan. But you predicted that he will repay the loan. You predicted that he will repay the loan. Actually, this person is not going to repay the loan, but you have predicted yes and you have approved the loan. Loan was approved. As based on your prediction, loan was approved. But he is not going to repay. Now, what happens in this situation? The bank will get the loss. That is Vijay Mallya condition. Right? They predicted that Vijay Mallya will repay the loan. And they have lended the loan. SBI Bank or PNB Bank or whatever the banks which were lended to Vijay Mallya or Nirav Modi, to whomever the X and Y persons, they predicted that they will repay the loan. But now this answer, predicted answer is yes, sir. So they have lended the loan, but actually he has not repaid the loan. Now in this case, this is going to make a problem for us. So here we have to focus our model, which will not do this type of mistakes. Otherwise, bank, for example, I'm giving for 10% loan. And these 10% are repaying for me interest of every month 1 lakh rupees. They are repaying as an interest only. Assume. For 1 year, I am getting 12 lakh rupees. For one person, I have given 10 lakh and he has not paid the repaid. Then whatever the profit I have got, everything is loss. Nothing is there. right? Every quarter, HDFC Bank will have around 400 crores with respect to NPA, non-performing asset. A non-performing asset means they will not give the returns. Means that is nothing but defaulters who are going to default the loan and they will not repay the loan. Based on that 400 crores, every quarter they will get a loss. Means yearly 1600 crores, they will get a loss on that, approximately. Profit around 10,000 crores. In the 10,000 crores, actually 10,000 plus this 1600 also should be positive. Total they have to get actually 11,600 crores actually they have to get. But due to these people, whoever has taken the loan and they are not repaying, the bank is getting with respect to just 8,400 crores only. 10,000 minus 1600, which is 8,400. Right? Annum, per annum I am saying, not per quarterly. Right? So approximately, this is example of just to have if you observe the financial results of the past year with respect to the HDFC Bank, you can check that one, right? Sir, by understanding both ML values should give the same. You see, so you are going to try with machine learning algorithms, multiple machine learning algorithms, one algorithm, two. Already I have told you for regression, right? So in the regression, which algorithm you are going to select? Which algorithm gives you the maximum R square or less RMSE? RMSE should be less or R square should be high. Any one or any one. No need of both. Of course, both will be the same. Okay, if R square is high, means automatically RMSE should be low only. Accuracy is high, means misclassification rate should be low only, right? Obviously. Right? Now, in the regression, we are going to focus on this part. Whereas for the classification, based upon the requirement, we have to focus. By default, it is accuracy. If they don't give anything, by default, accuracy. But in the problem statement, they say that I require the ML algorithm which will predict with low FN values. Then you have to focus only on the FN value. For algorithm 1, you have to check what is the FN value. For algorithm 2, you have to see what is the FN value. For algorithm 4, you have to check FN value. And like that for all the algorithms. And finally, you have to decide which algorithm is the best one. That algorithm you have to save. Right? So you'll understand one by one. Okay, one has to be selected. That will be based on the problem, given problem. That is called as business problem understanding. You are going to spend for 1 week, right? At the time, you have to think of all these things. Okay, if it is loan prediction, for loan prediction, which is more important? You have to analyze all these things. Okay, for the loan, if I give for a wrong person, if I give a loan, miss, what happens? For example, 1 lakh, I'm having 1 lakh with me. If I get given for the person, estimating that he will pay 1,000 rupees per month. Per annum, I will get 12,000 rupees. I'm estimating per annum. Assume. And I'm thinking that I will get a profit of 12,000. But I have given to a wrong person, means forget about this 12,000. 1 lakh also will be gone. If everything goes positive way and there is no corruption, means correct persons only, they will lend the loan. Machine will always give the best answers. But in between, bank managers, they'll be getting corrupted, right? Sir, if you give for me 10 crores, I will give for you 1.5 crores. I will send to home 1.5 crores. Now, for 10 crores, we have to get the loan. Actually, machine says that don't give 10 crores for SRK. Machine says don't give. But what I am going to do is, I will speak to the manager that I will send 1.5. 15% I will give as a commission. Gift. Okay. I will give as a gift of 1.5 CR. Now, this bank manager will be interested based on that. Okay, SRK for 10 CR. If they give the 10 CR to the machine, means machine will show that not accepted. Now, there is a loophole in the mission. What is the loophole? Now, multiple algorithms are there, out of which one algorithm will give the predict the SRK give the loan, right? That algorithm I will select. That algorithm I will select, and I will manipulate the data accordingly. And I will give the machine to give the output such a way that give the loan. I will make like this. And I will take the printout of this and I will keep in the file. So that tomorrow someone finds me also, officially everything will be there. Sir, in the machine only I have given all these things. Whatever we do for others, we have done the same thing for SRK also, and we have lended the loan. But when CBI comes into picture, they will check into the back what is the algorithm was given and why for others it has given like this, for this one, from where you have seen and how you have given the input and what are the documents you have taken from him and how you have given. Now what I'm going to do for tense, for example, let us assume 10 CR means very huge amount. Now. For example, actually 1 CR I want. Okay, based on my salary, whatever my salary is there, based on my salary, I will get the 50 lakhs as the personal loan. Assume, example only. Purely example only. Assume that I will get generally. Really, I will get with respect to 50 lakhs by showing that my salary is 5 lakhs per month. Example again. Okay. Salary is 5 lakhs per month. Example, where I will get a loan of generally without doing any kind of manipulation. Generally, I will get this one. Now I want 1 CR. Now what I am going to do is I'll project myself that I will get the 10 lakhs per month as the package. For that, what I'm going to do, I'll create a dummy payslips. Multiple payslips that I am working for multiple organizations. That too, recently only I have joined. Last 3 months, they are paying for me 10 lakhs every month. I'll project myself like this. Because banks require for personal loan, the rule is for personal loan is we have to focus only on the 3 months record. If there is a payslips are available. If pay slips are not available, means ITR we have to go. That is different story again. So now they are focusing only on the 3 months pay slips, and the 3 months pay slips, fake receipts I'll create. Okay. That is name of the company is X, Y, Z, I, J, K, A, B, C. This company is paying for me 3 lakhs. This company is paying 3 lakhs. This company is paying for me 4 lakhs. I will create a dummy fake pay slips. And this company names I will register officially. And I will give the salary for SRK for 3 months. These 3 companies also mine only. My own companies. I will only create the companies. From my account only I will transfer the amount. Officially as a salary. Okay. But these 3 I will not keep on my name. I will keep on XYZ. Some student 1 name, student 2 name and student 3 name. Okay. And I will do this one. And once I get the pay slips, I generate the pay slips like 10 lakhs per month. 3 months continuation, I will get like this. And I will project to the bank that I will get the 10 lakhs. Now, after 4th month, all these companies will be closed off. Work is completed now. Those 3 months, the company is there and they have given the salary. What I can do? This is called as manipulation. What happens in the industry? Actually, the machines will predict properly only, but these all the things will be manipulated. The bank managers, so I'm getting 1 crore. Bank manager, if I give a 15 lakhs gift means, they'll ask, sir, create 10 lakhs pay slip, sir. We'll manage everything. So I will create that one. One person will come for checking that one also. For that person, if I give 1 lakh rupees, okay. All the companies are available in Hyderabad. Every company is available. Money only, na? Right? So in this way, we are getting with respect to the loss for the banks. But actually, with respect to if you go with genuinely miss, the machines are this. That is the reason we are having with respect to loan prediction data as the one of the top machine learning project. Many of the finance companies still require this one. Okay, if you keep this one in your, that is loan prediction and credit card for fraud detection, these are the some projects are available. These projects will have them weightage in terms of finance related companies. If you're applying for finance companies, these projects will have the weightage. Right? So we are going to do one of the project related to that also in the future. So before moving to the project, first we have to analyze all these things. Right? So from morning to evening, we'll sit like this only, right? So in the office, from morning to evening, we are sitting and we are analyzing only. So first business problem understanding, first 1 week, we have to analyze the data. No need to check the data set also. No need to check whatever the variables are there. They'll not even share the data set also. They'll say that loan prediction. SRK, we are going to work on the loan prediction. Oh, loan prediction. What loan? Personal loan. Okay. Now let us understand what is meant by personal loan. How they'll approve that one. What are the parameters they are going to consider? How the bank will process generally a personal loan. Everything we have to do the research in the Google. Otherwise, we have to go to the bank also if necessary. We are not able to understand this. We have to go to the bank and we have to say, sir, generally I want personal loan. What are the things you require? We have to ask like this. Right? That is called as with respect to correcting the data based on the surveys. Algorithm name is called as logistic regression, but it is a classification related problem. Now the question is, sir, it is a classification algorithm, but why the regression word is there? That is the interview question, and you have to answer for me at the end. Why there is a word called as regression in this? They have to keep it as logistic classification algorithm, na? But why they have kept as logistic regression? You have to tell me the reason behind that. That is the interview question. Why regression was given for a classification algorithm? Okay. So let us understand the first theory part of logistic regression. Then we'll move on to the practicality. That is logistic regression. For example, if you are having a salary versus experience, this is a continuous variable and this is also continuous variable where the output variable is salary, which is a continuous variable. So you are going to apply on the regression algorithm. You are going to take the linear regression. You will apply the linear regression for this. Whether if it is a simple linear or multiple linear, you will apply the linear because the output variable is salary, where the salary is continuous variable. So for continuous variable, we'll apply the simple linear regression or multiple linear regression. Right? Regression concept will apply. All right. Where the regression line is used for prediction purpose by creating the y is equal to b0 plus b1x. That is beta naught plus beta 1x. Right? Now the question is, in the output variable, I'm having discrete variable, either yes or no. Now, if I apply the scatter plot will be only with respect to, for example, if I take a data set like this, input and output. Input age is 24, 26, 29, 44, 24, 24, 49, 36, 35, something you are having like this. Output variable, yes, no, yes, no, yes, yes, no, yes, no, yes. You are having like this. Now, if you make a scatter plot between x and y, what happens? For 24, yes, yes means with respect to, let us take as 1, no means 0. Yes means 1 means for 24, 1. This is the scatter point. Where y is 1. 26 with no. 26 no means this is the point. 29 yes. 29 yes means this is the point. 44 yes. This is the point. 24 no. Again, this is the point. 24 no. One more point. So either you'll have with respect to on the y-axis, you'll have only on zeros or ones only. For any x value, output is y is only 0 or 1 is there means the scatter plot will be like this. If this is the scatter plot, for this scatter plot, if you apply like this, the equation, similar kind of linear regression, how you have applied, if you apply a linear regression like this, what happens means multiple values will be wrongly predicted. Multiple values will be wrongly predicted. So that is the reason what we are going to do, this one, we are going to convert like this. Just we are going to have a prediction line in terms of like this, which covers the maximum number of data points. So either zeros or ones we are having, right? So these points I'm going to connect like this. This is the curve. So the curve just I'm going to take as a S curve, which is called as sigmoid curve. The S curve is called as sigmoid curve. So it is going to work on the function called as sigmoid function, right? So the curve, I'm going to convert this one like this, where it combines maximum number of zeros and ones. Sir, in between some values are there now. In between values, what I'm going to do is, I'll explain, right? So here we are going to consider with respect to the line, instead of going with a straight line, we are going with a new line called as sigmoid line, nothing else. So in the previous case, we are having a straight line like this, that is y is equal to beta naught plus beta 1x. Now, sigmoid function, you are going to apply this y value. First, you are going to apply linear regression only. That linear regression, you are going to substitute the values in this y. Whatever the y you have got here, that y you have to substitute here. And that it is going to give the probability as the output. Now the predicted value is, what is the predicted value? Probability. It is going to predict the output as probability. Whatever the value you are having here, just you are going to substitute here and it is going to predict the probability as the output. Now when it is predicting the output as probability, now automatically the values will be between 0 to 1 only. All the probability values lies between 0 to 1. The curve cannot cross more than 1. You can't get the values more than 1. You can't get the values less than 1, less than 0. It is not possible because all the values between 0 to 1. So now just here, whatever the value you have got here, y value, for example, y you have got as 400. Substitute that 400 here, 1 divided by 1 plus e to the power of minus 400. You will get some value. If you are having y is equal to minus 400, substitute minus of minus 400, that is plus 400. Right? So whatever the value you have got here, the y, just you have to convert to corresponding probability, is called as sigmoid function. So this is nothing but 1 divided by 1 plus 1 by e to the power of y, which is 1 divided by e to the power of y plus 1 divided by e to the power of y, which is nothing but e to the power of y divided by e to the power. This is also equal to e to the power of y divided by e power y plus 1. Is that clear? So when compared to numerator, denominator is more means automatically the value should be less than 1 only. It can't be more than 1. 100% it has to be because denominator is more. Whatever the value substitute here, when for that 1, above value is 10,000. 10,000 divided by 10,001. 40,000. 40,000 divided by 40,000 plus 1. Automatically the value should be less than 1 only. It can't be more than 1. Right? This is called as sigmoid function. Sigmoid function where it is going to convert the y value to a corresponding probability. Right? Now, this formula is equal to ln of p divided by 1 minus p. Both are same. So now the question is p is equal to 1 divided by 1 plus e to the power of minus y. So that is nothing but 1 plus e to the power of 1 plus e to the power of minus y is equal to 1 by p. E to the power of minus y is equal to 1 by p minus 1. E to the power of minus y is equal to 1 minus p divided by p. E to the power of y is equal to p divided by 1 minus p. Just I am 4 to the power of minus 1. I am doing whole to the power, just reversing. Right? Now, just I am applying the log e. Similarly, log e on the both sides. I am applying log e on the both sides, which is nothing but, now this is y is equal to log e p divided by 1 minus p. Log e is written as ln. Log to the base 10 is written as log. Log to base e is written as ln. Generally, it is written as ln. Log to base 10 only is written as log. Log to base 10, apart from base 10, if you want any other number like log to base 2 means you have to write that number. For 10, you don't need to write any number. By default, it is 10. ln means equal to log e. The meaning is log e. ln is nothing but log e. So ln of p divided by 1 minus p. So that is the reason. Y is equal to, this is nothing, y is nothing but beta naught plus beta 1. So the same y is equal to p divided by 1 minus p. Is that clear? This is the derivation. Of course, this derivation is not important. Okay, but you'll ask the question how we have got this one. So that is the reason I have shown you the derivation. Right? Now, so here, for example, let us take a data set x and y. You are having a data set of x and y, where in the output variable you are having 0, 1, 1, something like this, yes or no's, which is converted. This is label encoder I have done. After applying the label encoder, you are having like this. Before to label encoder is yes or no's. Now, x values, you are having some x values. Randomly, some x values are there. Now, what you are going to do? First, you are going to calculate y is equal to beta naught plus beta 1 x. And based on that, first you are going to predict the y hat. So whatever the y hat you are going to predict is based on the linear regression. So now y hat is a continuous variable. So you are going to predict the y hat is as a continuous variable. Y values can be anything. It's not going to predict as 0 or 1. It can predict anything. Now automatically after predicting the y hat, now you are converting this one to probability. Probability is nothing but which is equal to e to the power of y divided by 1 plus e to the power of y. Or equal to 1 divided by 1 plus e to the power of minus y. Both are same. So just by substituting this one, now you are going to get the, for each record corresponding probability. Earlier you have got it with respect to y hat. Now that y hat was converted to probability. Now you are having the probability values. The probabilities are, let us take, tell me anything of your choice. You only tell me. 0.5. Huh? 0.3. Probability can be from 0 to 1 only. And neither can be negative or it can't be more than 1. Probability means 0 to 1. Any value as per your choice between 0 to 1. Only positive. Probability never can be negative. Right? 0.95. 0.11. 7. 0.79. Something you are having like this. Now, once the probability, the model was predicted like this. Now, once the probability was predicted, now what we are going to take is threshold value. Some threshold. Threshold is wherever the p-value is greater than or equal to 0.5, convert to class 1. Just applying the discretization, converting the continuous variable to discrete variable. Discretization concept. Wherever the value is less than 0.5, convert it to 0. Now, now what happens? Now it is equal to 1. This one 0. This one 0. 1. 1. 1. 1. 1. 1. Now you are having actual y and predicted y. Now you can calculate how many true positives, true negatives, everything you can calculate. Is that clear? So just logistic regression works on the concept called as probability. After the probability, it is going to convert based on the threshold value. By default, the threshold is 0.5. If you want to change, sir, for example, if I change the threshold as 0.1, sir, any value greater than 0.11, any value less than 0.10. Now, 1, 1, 1, 0, 1, 1, 1, 1, 1, 1. It is going to predict like this. Right? So based on the threshold value, by default, the threshold value is 0.5. You can change the threshold value also. So logistic regression works on the concept called as probability. First, it is going to predict the output called as probability. This probability later it is converted as discrete variable. So logistic regression predicts what? Probability. Logistic regression predicts the probability for the given data. So probability is nothing but continuous variable. So that is the reason it is called as logistic regression. It is predicting the regression values only. Actually, it is predicting the probability only. Later, it is converted. Logistic regression by default, it is not going to convert that one. Later, it was converted as with respect to this one. So basically, it is predicting the probability based on the discretization technique. You are converting that one. Is that clear? So in this case, what just happened is just converting that one value to probability, nothing else. Okay. So logic is very simple logic. Linear regression, if you understand, means apply that value to probability. Sigmoid function completed. Logistic regression is probability of linear regression. Is called as logistic regression, basically. So just you are calculating the linear regression. Linear regression is nothing but y hat is equal to beta naught plus beta 1x. Now the same thing you are calculating the probability, which is equal to ln of p divided by 1 minus p beta naught plus beta 1x. That is, from this, you have to calculate the p value. Whatever the p value is there, that is, p is nothing but 1 divided by 1 plus e to the power of minus beta naught plus beta 1x. Nothing but same to same. As it is, no difference. Only difference is, instead of stopping here, we are continuing from here. Extra there. Extra is converting to probability, is the extra. Right? So here, what we are going to do is just considering a simple line. Instead of that, we are going to take a probability line. Now, for different values, we are going to get different probability values. The probabilities, if you take the curve, automatically the value should be 0 to 1 only, right? The curve will be between 0 to 1. It can't cross more than 1. It can't be less than 0. For different values, see, if the output is, for example, probability is 0 means these are the probabilities of 0, probability of 0.1, probability of 0.2, whatever the probability is that, just corresponding x value and corresponding probability. Just make a graph. Okay, graph between x versus corresponding probabilities. Now you are going, so it is going to predict the probability. Basically, it is going to predict the probability. Now, after predicting the probability, now you are going to take a threshold value. So for different values, it is going to predict the corresponding probability values. Basically, it is predicting the corresponding probability values. For these probabilities, later you are going to take some threshold values. Threshold of 0.5. Any value greater than 0.5 is considered as 1. Any value less than 0.5 is considered as 0. If the threshold changes, prediction also changes. If you change the threshold to 0.6, values changes. Predicted values changes means automatically confusion matrix also changes. For 0.7, prediction value changes, automatically confusion matrix changes, automatically TP changes, FP changes, everything changes, right? Everything will change. For different thresholds, we are going to get different TP values. For different thresholds, different TP values. For different thresholds, different FP values. For different thresholds, we are going to get different values. Now, then which threshold is best, sir? The question is how to select this threshold. So we are not going to select the threshold. So that is called as, next concept called as ROC. Next concept is called as ROC. For different threshold values, you are going to perform the TPR versus FPR. Okay, for different threshold settings, you are calculating the TPR versus FPR, and which model gives the best area under the curve, that model is best. So you are going to draw a curve between TPR versus FPR at various threshold. Now, many of the students will get confused. So for them, once again, I'm explaining. Now let us take actual Y. Okay, nice, actual Y. Tell me some, I'm taking with respect positive, negative, positive, negative, positive, negative, positive, negative, positive, positive, instead of negative, positive. Okay, we'll change. Otherwise, everything 0.6 only, na? Okay, let us change one. Now, this is actual Y. Now, predicted Y. Predicted Y. Predicted Y. First, you are going to predict the P value. Tell me some P values as per your choice. 0.6. 0.7, 0.1, 0.9, 0.2, 0.35, 0.5, 0.8, 0.45, 0.54. Okay, completed. Assume these are the P values, fixed. Now, this is the predicted. Now you take the threshold of, first threshold of 0.1. Threshold of 0.1. Okay, any value greater than or equal to 0.1 is considered as positive. Any value less than this one should be considered as negative. Now, according to that, now tell me whether it is a positive or negative. Greater than or equal to. Threshold value also always includes. This is 0.2. Right? Now, this is the actual Y. This is the predicted Y. Can you calculate the TPR value for this? Can you calculate? You know the formula for calculating TPR? You know the formula for calculating FPR? You'll calculate? Done. Next. I'm making a graph. Graph is with respect to threshold of 0.1. For threshold of 0.1, TPR value, what are the TPR value I'm going to get, and FPR value. This is FPR and this is TPR. For threshold of 0.1, I'm going to get some value, something like this. TPR versus FPR. Two values are there. Two values, can you make a single point on the scatter plot? You can keep a point, right? On the graph sheet, you can keep a point, considering this one as on the x-axis value and this is y-axis value. Surely TPR and FPR rate only, so it is going to be less than 1 only. It can't be more than 1. Assume it is 3.3 and this is 0.2. So you are going to take 0.3 versus 0.2. Wherever the x value is 0.3, keep a point, and with respect to y is equal to 0.2, keep that one point. So assume that this is 0.1, 0.2, 0.3, 0.4, something you are having like this. This is 0.1, 0.2, 0.3, 0.4, something you are having. Now 0.3 versus 0.2, this is the first point. This is threshold of 1, threshold of 0.1. Now you go with the threshold of 0.2. Now predicted values are this one, positive, positive, negative, positive, 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 positive. Now for this TPR and FPR changes, because this is the actual and predicted value is this one. So according to that, FPR changes, TPR also changes. For now, whatever the values you have got, these two, you make a plot here, one dot. Completed. 0.2 also completed. Go with threshold of 0.3. Again calculate. Now again positive, positive, negative, positive, negative, positive, 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 positive. Now again calculate the TPR and FPR. Keep a point. For various threshold settings, keep a point like that. So automatically you will get with respect to a curve. A curve by joining all the values like this, you'll get a curve. This curve is called as ROC curve. This curve is called as ROC. Now it is clear ROC means? For various threshold settings, calculating TPR and FPR, the graph between TPR and FPR for various threshold settings is called as ROC curve. So ROC curve is created by plotting the TPR against FPR at various threshold settings. Is that clear? That's it, right? In the notes. ROC curve is plotting the graph between TPR versus FPR with at various threshold settings. Heading as ROC curve, down. Heading as ROC curve, down. You want with respect to spoon feeding, right? ROC curve, heading, underline. Okay. A curve between TPR versus FPR at various threshold settings. Don't write as it is whatever is there in the PPT. Whatever we feel, we have to write. We have to understand the concept and we have to write on our own words. Because we have to remember, we are not by-hearting. Right? Various threshold settings, as the threshold changes, automatically TPR changes, FPR changes. Now, actually, we are having only one curve. We are going to get a one curve. But here, multiple curves are there. What is the meaning of multiple curves? Means multiple models are there. For model number 1, machine learning algorithm 1, you are getting like that. If you change the hyperparameter tuning and after applying the latest model, again the TPR and FPR according to that it change, right? So then you are going to get one more curve. This is machine learning algorithm 2. You are having one more curve. Machine learning algorithm 3. One more curve for machine learning algorithm 4. Like this, you are having multiple curves. Now all of them, between all of them, which one is the best model? Means which has area under the curve maximum value. So for example, this is the model, blue is the model number 1. Model 1, machine learning algorithm 1. This is machine learning algorithm 2 or model number 2. Within the same algorithm, you have done the hyperparameter tuning and you have got the model number 2. Now, which is having more area? Blue line is having down more area or green line is having with respect more area? So green is the best one. The higher the ROC, the higher the AUC, the better the model. Okay. So if ROAUC curve is equal to 1, that is area under the curve is equal to 1, it is called as perfect classifier. Perfectly, 100% accurately it is going to measure. The higher the accuracy, higher the AUC, the better the model. In my case, predictor 1 is better than the predictor 2. Predictor 1 is nothing but green color, which is better than the blue color one. The higher the AUC, the better the model. AUC value is equal to 0. What is the meaning, miss? It is a imperfect, miss exactly opposite. AUC is equal to 1, miss perfect. Perfectly it is classifying zeros as zeros, ones as ones. Perfectly it is classifying. If AUC is equal to 0, means perfectly it is doing the opposite thing. That is, zeros are converted as ones and ones are predicted as zeros. Means nothing but if AUC is equal to 1, let us take AUC is equal to 1. If the AUC is equal to 1, means the confusion matrix you are going to get TP, TN, FP and FN. If this is the case, okay, let us take this is the case. If AUC is equal to 1, means you are going to get here 90 and here 10, 0, 0. If AUC is equal to 0, means just you are going to get this one, 0, 0, miss everything are misclassified only and every record is misclassified. Here don't apply the logic of 90 and 10. Don't apply that logic. Apply the logic of everything are correctly classified, everything are wrongly classified. AUC is equal to 1 means 100% accuracy. The meaning is 100% accuracy. AUC is equal to 0 means 100% misclassification rate. Accuracy is equal to 0. This is the question in the NASCOM exam. To my knowledge, 100 out of 100 you will get this question. Every student will get this question, if my guess is correct. Right? Every student will get this question. That AUC is equal to 0 means what happens? A is equal to 1 means what happens? Is that clear? So now it is clear for what is meant by ROC and what is meant by AUC. To understand ROC and AUC, first we have to understand the logistic regression. Otherwise, you will not understand the threshold. Na? The threshold word you have to understand means first we have to complete the logistic regression. That is the reason I have completed the algorithm also. Is that clear now? So now, which algorithms gives the output variable as the probability? That algorithms only applicable for AUC or ROC. Both AUC you have to do means first you have to do the ROC. Na? This is one of the ROC, this is another ROC. Both are ROCs only. Out of these two, which is best means which is having the below area, which is having the higher, that is the best one. Comparison you are doing. So now higher the AUC, the better the model. Now whatever the ROC is applicable only to the models which will predict the output as probability. For those models only it is applicable. Not for other models. Only to the models which algorithms gives the output as probability, that algorithms only. Now if you ask me the question, which algorithms means, as of now, logistic regression. Remaining things we'll discuss in the future. As of now, logistic regression. For logistic regression, the output variable is probability. So for logistic regression, we have to identify which gives the best AUC value. Within the logistic regression, we have to measure which gives the best AUC. Right? Out of all these metrics, sir, that is accuracy, misclassification rate, precision, recall, sensitivity, specificity, TPR, FPR, all these things. Finally, tell me only one, which is the best one, miss. Blindly, this is the one. AUC is the best one. But for some algorithms, probability is not measured. Nah? Then how you make the ROC curve then? Without probability, how you take the threshold values? Threshold is there, miss, above to this, below to this. Okay, threshold only not there, miss. From where you will do that one? In that case, accuracy. So for certain algorithms, accuracy, for certain algorithms, AUC. Is that clear? If you have any questions, you can ask me. In today's class, we have discussed TPR, FPR, TNR, FNR, specificity, sensitivity, and ROC and AUC. Remaining class, whatever the metrics was left out, along with that, logistic regression also. Now, all this implementation, whatever we have discussed from last 2 days, along with the logistic regression, I'm going to apply this one in the tomorrow's class in the Python. First, I'll apply the model and I will show you the probabilities. After applying for various thresholds, how it has calculated, that I will show you in the tomorrow's class. Right? Practical implementation we'll see in the tomorrow's class. Along with the one more algorithm also we can complete, that is KNN, which is a Lilliput algorithm. Right? And which is also called as lazy algorithm. Okay. Now, sir, can you please repeat the statement once again with respect to AUC? AUC is nothing but multiple ROs. AUC is nothing but area under the curve. Okay, area under the curve. Right? The higher the AUC, the better the model. If the AUC is equal to 1 means perfect classifier. Perfect classifier means perfectly it is going to predict. Right? That is the meaning. Is that clear? Pawan, is your question is clear? Or AUC relating to probability? Yeah, related to probability is nothing but this one. First, you have to plot the ROC. So you have to take the ROC curve first. You write in the notes ROC. For various threshold settings, you have to calculate TPR versus FPR value. And you have to make a curve. This curve is for model number 1. Assume that model number 1 is called as logistic regression. Model number 1. Now you have applied one more algorithm, different algorithm. Algorithm number 2, some algorithm. Okay. Using that algorithm, you have got this one, this curve. Like this, you have got a curve. Now out of these two curves, we have to calculate area under the curve. Below to this, whatever the area is there, that we have to calculate. But in the Python, automatically it will give. You don't need to calculate manually. Area under the curve, you don't need to do the integrations and you don't need to calculate manually. Nothing manually is required. The only thing is multiple ROC curves. If you're having multiple ROCs are there means out of that, which ROC is best? Means which ROC has AUC value as the higher value. That ROC curve is the best one. Right? So the higher the ROC, the higher the AUC, the better the model. So in this case, we are having model 1, model 2. So here green line is having with respect to higher the area when compared to blue line. So predictor 1 is better than the predictor 2. Better. It is not only better. Best means you have to get the AUC is equal to 1. When AUC is equal to 1, what is how we are going to get the graph, you know? The AUC graph will be like this. Let me draw. Okay, this is TPR versus FPR. Now you are going to get AUC value like curve like this. If you got a curve like this, it is equal to 1. Perfect horizontal and vertical line. Then the area will be 1, equal to 1. In that case, it is equal to 1. If you are having slight curve also, it is not going to be 1.